All right, the last set of transformations that we've done so far are reflections, and these tend to trip you up because there's some memorization involved here. Like, I hate to say it, but you're just going to have to memorize some of this stuff. But a reflection, just think about it. If you look in the mirror, you're seeing a flipped, right? A flipped image of what actually is represented there. So a reflection is when an image, a shape, is flipped over a line. So let's just look right here. Let's just pretend this line right here, which axis is this? Do you remember? I hope you said the X. This is the X axis. Let's just say that this weird form here that I ripped out of paper was flipped over the X axis. That just means that it would go shoop and flip over and be in the same position below the line here, okay? So that is what we're doing reflections. And, you know, you cannot count for some of these you can count. So I'll go through a couple of different examples here to help you kind of learn. And again, some of this you're gonna have to memorize, okay? So a reflection over the x-axis. I went ahead and I drew the original image here, okay? And our line of reflection, so this image, the line of reflection is what it's going to flip over. So our line of reflection here is the x-axis. Now, there are two ways you can do it. I'm going to start with showing you how to actually count the points from the line of reflection. So what you want to do is first establish your line of reflection. In this case, again, it's the x-axis. So it's this line right here. That is my x-axis, okay? So this image is going to flip over this line. So basically, it's just going to move from here as the image down below as the pre-image. And the new points will be the same distance from the line of reflection. So let's look at T. How many units is T from the line of reflection? Well, if I count 1, 2, T is 2 points, sorry, it's getting blurry, from the line of reflection. So I just go below the line of reflection. I stay on the same line. 1, 2 units right there. And that is T prime, okay? Pretty simple. Let's look at R. R is 1, 2, 3, 4, 5, 6, 7, 8 units from the line of reflection. So I'm going to stay on the same line and just continue past the line of reflection for 8 more units. 1, 2, 3, 4, 5, 6, 7, 8. And that is going to be R prime. Okay? Pretty simple so far. All right. Again, make sure you're labeling your points when you draw them out. Make sure you go ahead and put the letters that go with them so that you don't have to go back later and figure it out when you're trying to do your points over here. Now, I'm going to show you the function notation that goes with a line of reflection that is the x-axis. And if you'll, well, let's do this first. What is our new point for T? How do I name it? Well, how do I get there? I go to the left, 1, 2, 3, 4, 5, 6, 7, 8, and I go down 1, 2. So my point is -8 because I went to the left, and then because I'll go down, it's -2. Now let's look at how this point changed from our pre-image, our original point, to our image, our new point. Did the X change? It did not. If you'll notice, it's at the same place. T and T prime are at the same place on the x-axis, okay? What about the Y? How did the Y change? The number didn't change, but what changed? The sign. And if you'll look, positive, negative. So, how can we write a function notation to indicate how each point would change? Well, we always start with our x and our y is going to become, how does it change? Did my x change? Look back again, -8, -8. When I'm reflecting over the x-axis, does the x in my point change? It does not. So it's going to stay the same. It's going to stay x. And then what happened to my y? Look there, 2, -2. So the sign changed. So the way we write that is -y. But now I need you to understand this does not mean that you're going to make them a -y. In this case, when we read that, we need to read that as the opposite of y. So whatever y begins with, we want it to be the opposite. So on a number line, if you looked at the number 2, the opposite of number 2 is going to be a -2, okay? So when the line of reflection is the x-axis, our function notation is my x and my y become x -y, which tells me that my x stays the same and my y, I'm going to change the sign. So let's do one together, one that I haven't plotted yet. A is -2, 5. So my first point, my x, what do I do to it? Well, according to the function notation, I don't do anything. So letter A is going to be -2. What about my y for this coordinate? I have to change the sign, so it's going to be -5. Okay? All right, I want you to pause the video, and I want you to try to do point P really quickly. All right, point P, my x is going to stay the same, and my y, I'm going to change the sign, so it's going to be -3. All right? R, we've already drawn R, but we didn't do it. We can do that together real fast. It's going to be -5 and -8. All right? I'm going to plot these points really quickly so you can see what it looks like. Let's see. -2, 1, 2, 3, 4, 5. That is A prime. And then -3 and 3. Wait. 1, 2, 3. 1, 2, 3. And that is P prime. All right, so if I folded my paper right here on this line, this point would match up with this point. This point would match up with this point. They are a reflection, which again, it means that it went from here and it flipped, okay? It flipped across this line of reflection, all right? Now, if a line of reflection is the x-axis, my x is gonna stay the same. Guess what? If a line of reflection is the y-axis, guess what's gonna stay the same? The y, all right? So I'm gonna write for you, just as a review, it's getting blurry, I'm sorry. If the line of reflection is the y-axis, this is your function notation. xy becomes, all right, we're talking about the y-axis, so what did I say is not gonna change? Your y is not gonna change, but what is gonna change? Your x, you're gonna change your sign of your x, okay? So if you're reflecting over the x-axis, the x doesn't change. If you're reflecting over the y-axis, your y does not change, okay? All right, we're gonna keep going and we're gonna talk about what does this mean? X equals 2. What in the world, okay? Well, it just means that there is a line where every point on that line, x equals 2. So let's look at this. Let's look at what that would look like. So I went ahead and I wrote down several 2's for my x for several different points. So you could pick any number. I'm just going to start with 0. 2, 0. 2, 1. 2, 2. 2, 3. And 2, 4. Now, if I went and drew all these points, this is what it would look like. 2, 0, 2, 1, 2, 2, 2, 3, and 2, 4. Now, do you see how that's starting to form a line? What if I did 2, -1, 2, -4, right? 2, -8. if I connected all of those points, it would create a line. And every single point on that line, because remember, a line is just a series of points that are connected. Every point on that line, guess what my x is? 2. That's all that means, okay? That is all that means. So for this problem, this is your line of reflection, okay? So let's just look at 2 points really quickly. So let's look at my S. S is 4, 5. So be careful. Make sure you always start with your origin. 1, 2, 3, 4. 1, 2, 3, 4, 5. There is my S. Now, this is the problem where you cannot use function notation. You have to count units from the line of reflection. So S is 1, 2 units from the line of reflection. So S prime is going to be 1, 2 units from the line of reflection. Okay? There is no function notation when X equals something or Y equals something. There's no, if it's a number, there's no function notation. You just have to count. Okay? All right, let me give you another example here with Y. In this problem, Y equals -4. So the same concept, that just means that every point in this line of reflection, my Y is -4. So 0, 1, 2, 3, 4. Okay? So where is 0, -4? So 0, negative 0, -1, 2, 3, 4 is right there. 1, let's go this way. 1, -4. 2, -4. 3, -4. 4. All right, do you see where the line's going to be? The line's going to be right here. You'll notice that it's horizontal line. Okay? It's a horizontal line. And every point on that line, my Y coordinate is -4. Okay? Same thing here. You cannot use a function notation. There's not a function notation. You actually have to just count the points. So let's do point F. Point F is -1, 2, 3, 0. So there's point F. So how many units is point F from this line of reflection? 1, 2, 3, 4. So we go 4 more units from the line of reflection. 1, 2, 3, 4. And there is my new point. Okay? The biggest mistake that students make with this problem is remembering you have to go to the point of origin to plot your points, and then to name this point, I don't name it from here. I have to go back to my point of origin. So it is -1, 2, 3. Wait. Did I do that wrong? No. -1, 2, 3, and then -8. 1, 2, 3, 4, 5, 6, 7, 8. I just know what that is, okay? So my new point is -3, -8.